Okay, so period is the time it takes to complete one full motion. And Grace, what's the unit? What do we measure period in? Good question, right? So it's the time to complete one full motion. So what do we measure time in? Seconds. Yep, that is the unit for period. The unit is seconds. Okay. So while this is kind of a new concept, you've actually talked about period before. When we did the orbital motion, when we did circular motion, we talked about period being the time for something to go around one time. So you've actually seen this before, but it's been like 2 months since you've seen it, and you've done several things, including sleep a lot. So if you don't remember this definition, that's understandable. All right, good. Let's go to the next one here. Sebastian, tell me what you think equilibrium is.
I think equilibrium is just an overall, the balanced distribution of an object.
Okay, good. Balance of an object. You can think of it like as the center point of motion. You can think of it as the point where all forces are balanced. There's a lot of ways that you can say this. I like to call it basically the point of an object where the net force is 0. However, this idea of a balance point is a good one. This idea of a balance point is a good one. Okay. Look at us, more than halfway done, because this one you didn't have to do, so I'd count that as less than half. Okay, Evan, oscillation. Tell me what an oscillation is.
That's a system of objects, a system or object that goes back and forth repeatedly between.
Good. So it's an object or a system of objects. So it's when an object goes back and forth in a repeatable fashion. Okay, let's make our definitions better, because all of our definitions at this point are fine, but they're not great. So let's make them better. Period. The time to complete one full motion. Let's be more specific. That motion is an oscillation. So it's really better to say the time to complete one full oscillation. That's actually a little bit of a better way to think about it. Okay? So equilibrium, we said that's a point of an object where the net force is 0. It's the balance point. That is a good definition. We don't need to go too much in depth there. But let's try to tie in oscillation to these other two things. So it's when an object goes back and forth. So back and forth, this here. Okay, back and forth is essentially your period is. So it's when an object goes back and forth in a repeatable fashion. The repeatable fashion, again, this is that idea of a period. But one thing we also want to mention with oscillations is it's doing this oscillating, it's going back and forth about an equilibrium position. You got a pendulum that's going to swing from one side to the other. There's an equilibrium in the middle. That's the balance point where the net force on that object is 0. And so if you have this oscillating pendulum, there's always going to be an equilibrium in the middle. So if you're talking about oscillations, you're talking about going from one side to the other with an equilibrium in between, and the time it takes to do that is called period. So that's how all those things interact together. So let's do the last one, and then we'll jump into this. So the last one here, D, is something called restoring force. So what is a restoring force? The restoring force is the force that brings an oscillator back to equilibrium. Now, there's a lot more detail we're going to need about restoring force, such as is it always the same? Does it get bigger or smaller? What is it in? What causes the restoring force? But we'll get stuff a little bit later. I didn't want to go too in depth on the notes today. It's the first day we're all trying to get our brains about it. So we'll get into that a little bit later. But definition of so period time it takes to make one full oscillation. Equilibrium is kind of the point where the net force is zero. Balance point for an oscillator. Oscillation is basically a full around equilibrium, and restoring force is the force that causes that object to go to equilibrium. Not necessarily stop there. You'll see that with pendulums, they don't stop at equilibrium, at least not for. And we'll talk again why that happens, but now these are just the basic definitions. Anyone have any questions for me? All right.